Thank you so much, Nora. We have time for questions. Yeah, okay. I noted you, I think.
With regard to the studies involving the rectangular room with two sets of congruent corners, you pointed out that at a certain point, at least in the humans, they started to take advantage of the fact that one of the walls was colored. And then you went on to explain that the use of geometric information is acquired, but you didn't say anything more about the use of the colored wall. What is it that elicits the ability to use the colored wall in finding the reward?
No, I think you misunderstood what I was trying to say.
Yeah.
I'm trying to say that in an environment that's large enough to be even moderately ecologically valid, that as young as 18 months, you use both the length of the wall and their sense relationships, the geometry, and the feature, and that you integrate them. So it's all there at 18 months. Yeah. Now, I will say that leaves as a mystery why in the small room you find that transition. And there are various answers to that. But I don't want to go into them. And I don't want to go into them because I regard it as such a special case that I'm not utterly sure we ought to care. So there's that.
Thanks very much. You started off distinguishing between navigational abilities and smaller scale spatial abilities.
Yeah.
Can you say a little bit about where perspective-taking abilities might fit in there?
Right. So the trouble we have with looking at perspective taking is that if we want to measure it as an individual difference, we're not measuring it typically in a large scale environment. So the existing tests, Mary Hegarty has one. I came up with Andrea Frick. There's the Four Mountains test from Neil Burgess's lab. We have a paper in which we look at these various measures and see, do they correlate with each other and do they have desirable psychometric properties? The answer to that is that the Four Mountains test is really weird and I don't know what it measures, but the other extant ones do form a really nice scale. But they're all on paper and pencil. And some of them ask you to imagine being in a larger environment, but it's not really a larger environment. And I think for that reason, we're not measuring perspective taking in situ, so to speak. There is a very nice paper out of Neil Burgess's lab which compares mental rotation and perspective taking in the only way you can compare it, which is a vista space with several objects on a table. So it's not exactly about the objects, it's about the inter-object relations, but you can imagine the table moving or you can imagine moving around the table. And there's a ton of experiments with that general paradigm. But what this paper, it's Lambury et al., showed was if you ask people to think of themselves as moving around the table, you got navigational areas of the brain lighting up, and if you ask them to think about it as the table rotating, you get mental rotation areas of the brain lighting up. Oh, I forgot to say in contrasting them that they're reliant on different neural areas. But I think it's very difficult to do in practice, and we have so far not done it with psychometric tests.
Hi, so thanks for the talk. I was wondering, based on the mice experiment, we had the idea that how good you can orientate also depends on what you have experienced before, right? So whether you have only experienced the round place or the corner. So I was wondering if you think that that adolescent people still get better in orientation and are worse compared to adults. Maybe also is because they have experienced a less variable environment, so maybe they haven't moved yet and only have lived in one city, while an older person probably have seen or navigated through many different cities, or whether you think it's more of a neurological developmental progress.
Well, I really think it's both, and that also the brain develops given experience. So, but Yes, one of the characteristics of our species is attachment, and we certainly guard our young, we guide our young. So it's not just they haven't experienced a lot of routes, it's they haven't independently navigated or charted the way along a lot of routes. And that's getting sort of worse and worse. Like, you don't let your kids walk to school alone until they're 10, and so in many areas of the US. Now, that though, means that there's room for a lot of studies of cultures in which that's not true. So, for instance, some people I know are right now looking at the Faroe Islands, where kids are allowed apparently to roam around quite a lot, and looking at some of their developmental timelines. And I think, not at their brains, but, I think that that's going to be really important. Independent navigation, as well as perhaps variety.
Hi, thanks very much for the talk. I wondered if you could say a bit more about evolution and the sort of experience expectant alternative to modularity. And I was really struck by the idea that you presented more typical environments for us to have evolved in, which do not have the geometry. But then what seems to be happening is that in your mice experiment, that the mice are very susceptible to that information about a very geometric setting. And at first that seemed to be very strange, that how could we have evolved a system which is waiting for information that shouldn't be there? But I suppose I wondered what you would say about that, and if there's different types of geometric information or spatial information that might be useful to this system.
Well, I actually think it's really a neat trick of evolution to involve something that is going to be expected of an environment, because that gives it, well, first of all, a certain flexibility that it would lack if there were more tightly hardwired, especially hardwired representations. And also, it's probably easier to build an expectant system than to build a hardwired system. So I think of this as analogous to when people are trying to build computational models. People don't like hand-wired computational models. They like models that can learn. And I think Mother Nature likes that too. So I guess I sort of just see the whole thing differently.
Yeah, great, wonderful presentation. So mine is actually kind of following up on the same topic. As someone who's also struggled against nativists who will declare victory no matter how the data turn out, I'm very sympathetic. But I also wanted to follow up on this experience expectancy issue. So you probably know this already from being in these debates, right? The worry is that if the experience that's expected is only domain-specific spatial knowledge, then they're going to say, oh, that's all we meant all along, right? All we meant was that, that's not learning, that's activation or acquisition. So the next step where the debate can go after that, and this is the way it goes in neural networks in some cases, which I'm more familiar with, right, is to say, yeah, of course, as empiricists, we want to say, well, evolution is important and evolution should prepare you to learn efficient methods. But what evolution builds into the system is not domain specific in the sense that it can only work for this one thing. Right, so in neural networks, I think a winning move at the next step is to say, well, what it's built in is a bias towards translational invariance or something, whatever it is in the particular case. And that works just as well for non-spatial learning situations too, like auditory data, right? You can show the exact same neural network architecture that has a bias towards learning. Translational invariance and spatial data efficiency also works well in learning translational invariance and say auditory processing and so on. So I guess the question is sort of like, do you have anything like that you can show in this case to say, yeah, sure, it's very efficient at acquiring geometric information, but that's not all it can do. And so you shouldn't see it as just like a kind of acquisition or activation of latent geometric knowledge.
Well, actually, I think I differ a little bit in my views from you, because I would not call myself an empiricist. I'm trying to steer a course a little bit between nativism and empiricism. And so I don't actually object to the activation word, other than it sounds like flip a switch. And I think it takes a little time. So maybe a little different word than activation. But I actually do think that given some of the work at the level of the cells, these cells spring into action to do some quite specific things. And I would be amazed if they also did something relevant to auditory learning. So, well, they can say that. I mean, you can come up with lots of quotes to say that isn't what you said all along. And there's a way in which I guess I would be a nativist if they would just be a lot more careful. I mean, that's really what I feel.
I think I forgot some of the early hands on this side, but maybe not. Then I go to Nick.
So this is on the same line. It's a very interesting distinction between experience dependent and experience expectant. And sometimes you were talking about it as kind of a trigger, and other times as if it's learning, but it's it's quite canalized learning, and so you don't get the same variation depending on experience that you get with experience dependent. But so if it is learning, how are you picturing the learning in the experience expectant case? And what would make the difference between it being learning versus triggering in the kind of paradigms you're thinking about?
Right. Well, I think it depends on what you think you're committing to when you use the word learning, and whether or not you mean some protracted series of rewarded connections or something like that. I think that, and that's actually where you get a little at the time issue that I talked about, where activation sounds like you're flipping a switch. And there's only some examples of that in the literature. So, as I think about it, the imprinting work where you follow the first moving thing and it turns out all it has to do is, have some very rough shape and, that kind of early work. That is flipping a switch. Because it is just the first moving thing. I don't think the ducklings need a lot of experience following Conrad or anything like that. And so that would be experience expectant, but I think you would not call it learning. So yeah, no, that's an interesting point, that there's probably several types of experience expectancy. I think with other situations, you may need to see some set of multiple instances. They wouldn't necessarily have to be rewarded, though, because for our cognitive system, there's the internal reward of being right. Like, I don't have to get a chocolate pellet or a little duck. So, for example, one idea that is claimed to be innate is the idea of gravity. But in a world that actually has gravity, all you have to do is have a visual system that's acute enough to notice that everything that's dropped seems to hit the floor. Now, how many times do you need to see that and not see any counterexamples where you drop things and they float upward, which happens sometimes, like balloons. But, to notice that by far the preponderance of things hit the floor. These are the kinds of questions we haven't asked because the infant experiments on, oh, look, 3-month-olds expect gravity, are just taken to show that it's innate. In the few times that we've looked at development, so I don't know if you know, there's a famous Kelman and Spelke study from decades ago, which shows that you expect that a moving bar that's occluded by a screen, that the two parts, because they have Gestalt, common fate, are joined. But actually, if you do the experiment with young enough infants, they don't look surprised. That was shown a little later by Scott Johnson. And in fact, there's a very nice titration where they do show it if the occluding bar is really very thin. And then as they get a little older, they can tolerate fatter and fatter bars. So at some point, I guess you just have Gestalt, you just are a Gestalt creature. But so in that case where you have documented that it comes from experience over time, I think it's a little different. And yet it is experience expectant, because in our world, if things move together, they probably are joined up physically. Either that or it's, water ballet or something. But there aren't a lot of counterexamples.
Thanks for the beautiful talk. I have two small questions. The first one is concerning the data that you show with mice and infants, where there is this qualitative shift in the development of hippocampus, and that relates to the change in the performance between, I guess, 16 and 20 and 21 and 24 months, whether you think that's a critical period and whether, that can drive like the design of future experiments to address this kind of hypothesis. And the second one is related to language. I apologize if I misunderstood, but in the first part of your talk, you seem to dismiss a role of language in the development of these spatial abilities. But then you show in the last part of your talk that, there is this continuous change in development until the adolescence and maybe later. And whether you think, I know the work by Sue Carey and Ackman and other authors who suggest that learning certain words can help discovering certain abstract relations. And so whether you think that process may change the way in which older children and maybe adolescents perform this kind of tasks.
So I would not want to be understood as saying that spatial language is unimportant. I think it's a really powerful symbolic tool, along with making physical maps and gesturing and all the other kinds of symbolic ways we have of communicating our knowledge with each other. I mean, if nothing else, it augments knowledge because I can tell you how to get somewhere or show you a sketch map of how to get somewhere, and you don't have to just find it out for yourself. A much more fraught question that I think you might be asking is whether a particular language's spatial terms have a very deep effect on spatial understanding. And there's a large contentious literature on this topic. My own view is more aligned with Lila Gleitman than with Steve Levinson. And I don't think that Lila Gleitman, far be it from Lila, would deny the power of human language. I think her point is that it's the icing on the cake for bedrock human spatial cognition, so that now, the demonstrations that you construe situations differently depending on the language, I think can be understood as sort of first-line defenses, that you're likely to have meant X, because that's what everyone in my linguistic community means when they say X. But if it turns out that that isn't what you mean, you can move to the other way of talking. So left and right are famously very confusing terms because it depends on your point of view. We do not say that, Dora is on the north side of the room, although I think that's true, but I'd have to check it. But it would be a very strange thing to say. And yet it is, in a way, a better way to describe her position, because it doesn't then matter, where you are or what, but it's just we don't use it, so we don't use it. And I think that's the view that I would subscribe to. We could use it.
Thank you so much. With the implications of the powerful emergentist perspective you've given, where cognitive maps are, I guess, an achievement, they have to be made, and as you've shown, environment, context, development, and individual variation play such an important role. So presumably, even though there are some cases where the resultant achieved map is fairly rich, there are many cases that, as you've shown, in which they are less complete, they're more partial, more fragmentary, more selective, more collage-like perhaps. So my question is, do we need a kind of lower bound on where we as theorists are willing to posit cognitive maps, or is it okay to think that there's going to be a fuzzy boundary, maybe no single necessary condition for where we use that construct?
I don't know. I think it's okay. It's to have a continuum. It's an interesting question about a lower bound. I don't think. I think the lower bound, there's a way to set it because there are, thankfully, only a few individuals who truly are so disoriented they can't be trusted to, walk anywhere at all. Interestingly, or to drive or so forth. Interestingly, one example of that are children with developmental amnesia, the children that have been, looked at in detail by people like Varga Kadem, who do show a pretty much normal ability to learn things in school, to learn semantic facts, but have both very poor episodic memory, which is one of my other interests, and really can't be trusted to ever find their own way even to, from school to home or vice versa. So there, and that is abnormal. I mean, so something better than that, but I don't know quite where to set it. Yeah.
Hi, thank you for the, is this, yeah, okay. So I pretty persuaded by these follow-up studies you did to the original Spelke room navigation issues, but I'm wondering how you would explain one piece of evidence that I've always found really striking from those studies that supports, I think, the idea that language is playing a sort of integrating role between the allocentric and geometric information, which is when you put adults in a sort of verbal shadowing condition, they seem to drop back to the chance levels, and I've found that to be really interesting, and I'm wondering what your sort of explanation of that finding would be.
Well, do I have a paper for you? Early on in this debate, I actually redid that experiment and added what I think is a crucial comparison condition, which is spatial shadowing condition. So in the original experiment, there was a rhythmic control. It's actually very difficult to do these experiments because the interference condition ought to be both matched in difficulty, but also be an interference that you might expect to be interfering. So rhythmic tapping can be pretty automated, so it doesn't really interfere. So I don't think it was a good comparison condition. Now, in the verbal shadowing, let me say that I have never failed to replicate Liz's effects. In the verbal, so it's not that is not the problem. Although in the verbal shadowing condition, we didn't get adults to go to chance, but they took a very big hit. So in that sense, it replicates. But they took at least as equally big a hit in a spatial shadowing condition, which is adapted from a visual imagery experiment that was done ages and ages ago by Lee Brooks. So I just recommend you look at our rebuttal paper for my rebuttal.
All right, so our time is up for questions. So we'll be moving on to a half-an-hour coffee break now, and then continue with the accompanying symposium with Roberto Casati, Pablo Fernandez Velasco, and Mizun Kim. So please come back for that symposium, and thank you, Nora, again.